and we are going to see one of the very important variants, which is of the maximization type. So it can be, the maximization problem can be solved into, two, specifically three ways. So I'll be telling you all three ways. Uh, we are going to solve it, firstly with one of the more complicated way. Other two are easy. So if do not get while I speak or explain, so we'll be seeing a numerical based on that as well. So no, it is not compulsory, or they won't be telling you to solve it by a specific method. It will be a maximization problem will be just given, and you can employ either of these three conditions to solve this numerical. So let's try and understand what is actually a maximization problem, and how we are going to handle this. So when we say that we have a maximization problem, and that is to be solved by transportation problem model. So that actually means, what is the, what is so surprising, or what is so different about it is that, transportation model in itself is a model that is made to handle the minimization problem. It is doing the minimization of the total transportation cost. But when we say that a maximization problem is to be handled by a model which is used for handling the minimization problem, then particularly there is something innovative, you can say something different that is happening, right? So hence, maximization problem solving using transportation model is something that is important, or something that is interesting. So let's understand how this can be, that how we can solve it. It is only a simple, what we can say, a simple understanding, or simple, some different step that we are doing that will be helping us to solve this maximization problem. So here, when we are seeing a maximization problem, normally it will be the maximization of the profit that will be, dealt with in the problem, right? So earlier we were dealing about the minimization of the transportation cost, but here it will be the maximization of the profit that can be told to us. So there can be many various ways, and a way particularly firstly is, we must understand a maximization function. Maximization function is equivalent to minimization of negative of that function, making you understand, right? So firstly, we should understand maximization function is equivalent to minimization of the negative of that function. So of that function matlab given function, right? So I'll be writing. So here you should understand the maximization function is equivalent to the minimization of the negative of that particular function, right? So how this particular approach we are going to deal with this? If I've been given the profit in positive, I'll be making them I'll be making them negative, and then by making them negative, I'll be handling this particular situation. Just I'll be converting it into a negative function, and then I'll be trying to solve that particular. So if I'm doing if I'm having a profit matrix, and I multiply it by all the entire profit matrix by -1, right? So I'm making it negative, and then I'm solving it by a minimization approach. So at the last, the answer that I will be getting will be the maximization of the profit only. So that we are going to see. So I think you are understanding what I'm trying to say is that, see, if I have been given a maximization function, and no, that maximization function is to be handled by a minimization model. So how that is to be handled by a minimization model? So if it is to be handled by a minimization model, so what we are going to do a change is that we are going to multiply the profit matrix by -1, and then it can be handled by that minimization model. And at the last, the answer that we are going to get is nothing but the maximization of the profit only. So you have to just understand this. So what I have told, I will be writing here. So the given problem or given matrix is converted firstly into a minimization problem by multiplying the profit matrix by -1. Minimization of the newly obtained profit matrix by usual transportation problem method will do maximization of problem. So I think that no, it is understood. The given problem is converted into a minimization problem by multiplying the profit matrix by -1, and minimization of the newly obtained profit matrix by usual transportation method will do maximization of the given problem. Now this approach, which seems to be a little bit complicated. So specifically, we are going to deal with a numerical on this particular approach only, so that I'll be making you understand. Nextly, it is that next approach is that the given maximization problem, it can be converted into a minimization problem, by subtracting all the profits from the highest profit in the matrix, and then solve it by usual method, right? So if I have been given a profit matrix, so in entire profit matrix, which is the which is the cell, which is the value which is having the highest profit, I'll be considering that, and I'll be subtracting all my individual profits from this highest profit. So when I do so, what will happen? I'll be getting a new profit matrix, and when I'll on the new matrix, I'll be applying the usual method, and I'll be doing I'll be handling that maximization problem in this particular way. So again, at the last, the answer that we are going to get is the it is the total maximization of the maximization of the total profit only. So lastly, I have one more method that it is also used. So what we can do is that let's solve this maximization problem by maximization strategy only. So it may be solved. It may be solved by maximization problem itself. Maximization problem itself. Right? We'll be solving it by maximization problem itself. So how we are going to do is that so while allocating the allocations, while doing the allocations, what we are going to do is we are going to select the cell with highest value. Now up till now we were doing the allocation in the cell with the lowest value. So here for the maximization problem, where we are going to do the allocation, we are going to do the allocation in the cell with the highest value only. And even for the finding the initial basic for a feasible solution. So for initial basic feasible solution, as well as for all the iterations, we are going to follow the same strategy, right? Lastly, when we are going to check, when we are going to check for the optimality. So for optimality check, what we are going to do is, for optimality check, all the cell evaluations should be negative. In minimization, in transportation problem, as of now we have seen that when all the cell evaluations are positive, we consider that the optimal solution is reached. But in this particular stage case, what will happen, the all the cell evaluations should be negative, then only we'll be deciding that the optimal solution is reached, right? So now these are the three methods. So now at least no, we haven't seen any numerical, but at least with my explanation, have you understood this particular strategy of handling the maximization problem? The first strategy we are going to going to discuss in today's practical session with the help of a numerical. But tell me if you have understood at least the theory explanation what I have told regarding handling of the maximization problem in your chat box. In chat box, you can tell if you have understood the theory explanation. We are going to see the numericals. The first one, which seems a bit complicated, we are specifically going to deal with it now, right? So many of you are saying that you have understood. So let's handle a maximization problem. I've taken specifically selected a bit different problem, so that few of the more concepts will also get clear, right? So let me start with the problem. So we have a company which has three factories. So we have three factories, and all those are manufacturing the same product only, and there are 5 cell agencies that we are having, which are located in the different parts of the country. Production costs differ from factory to factory, right? So different production costs are there. Production cost for each factory, that is given to us, and the sales prices from and the sales prices also vary from agency to agency. Also, right, the production cost is different for each factory, and also the sales price is different for all agencies. So the same product is there. If I'm manufacturing it in Mumbai, say in Mumbai, it is requiring 18 rupees. And let's say if I'm manufacturing in if in Pune, I'm requiring 16 rupees, right? Same product. So because of the availability of the resources, and depending upon those agencies, there are 5 agencies. So same product they are selling at different locations. So an agency in Punjab is selling the same product at, like, let's say 5 rupees. In Maharashtra, it is selling at 15 rupees, and somewhere in South, it is selling at to be 18 rupees. So the sales price are also not fixed, and the production costs are also not fixed. Those are varying with agency and factories respectively, right? So the shipping cost per unit product from each factory to each agency is known. So they have given the unit shipping cost, that is nothing but the transportation cost is given in the form of matrix, right? So given the following data, find the production and distribution schedules most profitable to the company. So they have given some given, or the representation of the information is done in a different manner only, right? So I'll be there are 3 factories. The production cost per unit, they have given it to be 18, 20, and 16. The capacity of factory 1 is 140 units, 190 units for factory 2, and 115 for factory 3. right? So they have also given some extra information. These are the three factories, and the shipping cost is given like this. So they also mentioned the agency. So 1, 2, 3, 4, 5. The agency that they have given to us. They have given the demand across each agency, and also the sales price has been given. Sales price that has also been given. That's somewhat a different no, representation of the data. So no. So all this what I'm writing are the shipping cost, unit shipping cost. 5, 6, 4, 3, and 8. So the demand is 74, 94, 69, 39, 119. Next we have 35, 37, 36, 39, and 34. All right. So all these are given to us. These are factories. All this 1, 2, 3 is a factory. I think that you have understood what this. So the profit matrix has been no direct profit matrix is given. This entire profit matrix is given in the hidden way. Now, let's understand this problem. Firstly, the very first step is now that we have to find out the profit matrix. We have to construct the profit matrix, right? So, how to construct a profit matrix out of this different information that we are going to see. So, firstly, if you know, normally what is the strategy? Sales price. What is a sales price? Sales price will be equal to what? The sales price will be equal to production cost plus shipping cost plus profit, right? So your sales price will be equal to the production cost plus shipping cost plus profit. Now what I want profit. So what I can write is profit is equal to profit is equal to how much? Profit is equal to sales price minus production cost minus shipping cost, right? Sales price minus production cost minus shipping cost. So can I make a matrix, profit matrix directly here? So I have 5 factories. So let's start with a simple construction of a profit matrix directly. So I have 5 factories, 1, 2, 3, 4, and 5. Nextly, it is first, second, and I have third factory, 1, 2, and 3, and I have to now Phillips. This is the nothing but this is your profit matrix only directly. Profit matrix that I'm constructed. So now the sales price and the sales price across each agency has been given, right? Also the the unit cost for each or the production cost of each of the factories is given, and also the shipping cost is given. So I have to just use this formula, put the value, and I can find out the profit matrix. So here you can see the sales price is 35 for agency 1. The sales price is how much? It is 35, right? So across the row, across your column 1, the sales price is going to remain constant, right? So for entire your column 1, the sales price is going to be 35, right? Now for column 2, the sales price here is 37. So entire for column 2, the sales price will be 37. For column 3, it will be 36. For column 4, it will be 39. And for lastly, for column 5, it will be how much? It will be 34, right? Similarly, for the factories, if you see, factories won't be having the factories won't be having the sales price. they will be having the production cost. So factories, you see, the factory 1 is having 18 production cost. So across all your row 1, the production cost will remain constant as 18, right? Similarly, for factory 2, you have a production cost of 20, and across your row 2, the production cost will remain constant as 20. For factory 3, you have a production cost of 16, and across all this, all this row, the production cost will remain constant, right? So we have to just do the we have to just do some calculations here. Let's now I'll be telling you how to do a calculation for a single cell, and then some random cells particularly. So now let's see this particular cell, which is cell 1 1, right? So agency 1 has a agency 1 has a sales price of 35. Factory A has a production cost of 18, and for cell 1 1 the shipping cost is 2. So what I can write is 35 minus 18 minus 2 is equal to how much? If you, use calculator, 35 minus 18 minus 2 is equal to how much? It is equal to 15. So I'll be writing somewhere here. So it is 35 minus 18 minus 2 is equal to how much? It is equal to 15. Right? I'm hoping that you have understood this. Similarly, for we are going to complete it row by row, so that the production cost will only remain similar. So for agency 2 now it is 37. The sales price is 37. So 37 minus 18, and the shipping cost here is again 2. So 37 minus 18 minus 2 comes out to be 17. Similarly, for next value in the row, the value, the formula will be 36 minus 18 minus 9, and the value that you are going to get will be 12. Similarly, the next formula for the next cell will be 39 minus 18 minus 6. Oh, sorry. Firstly, it will be 39 minus 18 minus 10, and that will be equal to 11, right? For the next, it will be for the last cell, it will be 34 minus 18 minus 5, and it will be again equal to 11. I'm hoping that you are using some calculator, or at least trying to understand what I'm trying to tell and understanding. Similarly, let's move for factory 2, where the production cost is 20. So now how I can write it as 35 minus 20 minus 10 is equal to how much? It is equal to 5. Similarly, for the next cell, it will be 37 minus 20 minus 8 will be equal to 9. Similarly, for the next cell, it will be 36 minus 20 minus 9 is equal to 7. For the next cell, it will be 39 minus 20 minus 4 will be equal to 15. For our next cell, it will be 34 minus 20 minus 7 will be equal to 7. Lastly, we have 35 minus 16 minus 5 is equal to 14. Nextly, we have 37 minus 16 minus 6 is equal to 15. Nextly, we have 36 minus 16 minus 4 is equal to 16. We have 39 minus 16 minus 3 is equal to 20. And lastly, 34 minus 16 minus 8 is equal to 10. So this is how the profit matrix is obtained. Now that we have obtained the profit matrix, we can move ahead with formulation of the transportation problem. So I'm hoping that everyone has understood the profit matrix. So let's copy this profit matrix on next page and formulate our transportation problem, which can be solved further, right? So I'm repeating the profit matrix here. The profit matrix here is equal to (15, 17, 12). It is 11, 11. Nextly we have 597, 15, 7. We have 14, 15, 16, 20 and 10. 1, 2, 3, 4, 5, 1, 2, 3. Right? So we have been given the supply. The supply across the factory 1 is 140, factory 2 is 190, and factory 3 is 115. So that was already been given to us. Similarly, the demand across each of this agency has been given. It is 74, 94, 69, 39, and 119. So this is the profit matrix and the formulation of the transportation problem that we have done. Let's check whether it is a balanced or unbalanced transportation problem. So the total supply that we have, the total supply comes out to be, if you do the addition, the total supply comes out to be 445 units. Similarly, the total demand comes out to be 74 plus 94 plus 69 plus 39 plus 119 comes out to be 395 units, right? So if you see here, we can say supply is not equal to demand, and again what we can see is supply is on the higher side than that of the demand. If such is the case, what we'll have to do is here add a fictitious agency to handle the excess supply. What is the excess supply? Excess supply will be 445 minus 395. No, it will be 50 units. Excess supply of 50 units. So now, if now only your supply will equal to the demand, and we have got the balanced transportation problem. We are going to find out the initial basic feasible solution, right? So for finding out the initial basic feasible solution, we are going to use the VAM method. 1, 2, 3, 4, 5. 1, 2, 3. So 15, 17, 12, 11, 11, 5, 9, 7, 15, 7, 14, 15, 16, 20, and 10. Okay. So before moving towards now particularly we forgot that this is a maximization problem, right? So basically I forgot that this is a maximization problem. So you can't start with the VAM solution directly, right? So you have to convert this maximization problem into a minimization problem, and then you have to start with the VAM solution, right? So before initial basic feasible solution is to be found, convert maximization problem to minimization. Convert your maximization to minimization. Now how we are going to handle this, right? So we are going to handle this by multiplying -1, right? So -1 will be multiplication of -1 to all this cells in the profit matrix, right? So here you'll be getting it as -15, -17, -12, -11, -11, -5, -19, -9, -7, -15, -7, -14, -15, -16, -10, sorry, -20, and -10. So I'll be copying it because we require one more step that we need to perform, right? So let's move ahead and So we have got minus 15, minus 17, minus 12, minus 11, and minus 11. Again, here it was, yeah. We have to consider a dummy agency as well, which will have the cost of 0, 0, and 0. So here we won't be giving any negative sign here, right? So minus 9, minus 5, minus 9, minus 7, minus 15, and minus 7, and you have minus 14, minus 15, minus 16, minus, no, it is minus 20, and minus 10, right? So these were the factories 1, 2, 3, 1, 2, 3, 4, 5. Here you can say this is a dummy, or a different dummy agency that we have considered. So here F or D. So we were using D. We are going to use D only here, right? So now what has happened? We have converted it into an entire negative matrix. Now if we solve this by usual method, no, you are going to get the answer. You will be able to solve it by the transportation problem. So, but don't you find it difficult to handle this negative signs? Previously only there were a lot of calculations to be done. Now that psychologically, again there is a difficulty level that has increased, because you have got negative sign, and when you have a negative sign, there are more chances to do the errors, right? So can we handle this negative sign as well, right? So what we can do is that I can identify the maximum value here with a negative sign. So amongst all these values which I have in the profit matrix, which are negative, I will be identifying a maximum value which is having a negative sign. Here in our case it is 20, right? So now what we are going to do is we are going to add 20 to all these cells, right? So we are going to add 20 to all these cells. But let's add 20 to all these cells and see the magic, what happens. Right? So 20, minus 15 plus 20 is 5, minus 17 plus 20 is 3, minus 12 plus 20 is 8, minus 11 plus 20 is 9, minus 11 plus 20 is 9, 0 plus 20 is 20. So here it will be 20, 20, 20. Here it will be here it will be 15, it will be 11, here it will be 13, here it will be 5, here it will be 13. Here it will be 6, 5, 4, 0, and here it will be 10. So now here you can see the profit matrix that we have got is a positive one, and now this particular seems, it seems you can say psychologically good that we don't have any negative signs, and now with this we can proceed ahead with the solving with the transportation problem. The only now the consideration of 20 is not to be done in intermediate steps. Only at the last step where we are going to calculate the profit, the significance or the consideration of this this addition of plus 20 that we have done in this step will come at the last. So now what we are going to do is we are going to find out the initial basic feasible solution of this particular of this profit matrix. So now I'll be making it a bit comfortable to solve. Right, so we have 1, 2, 3, 1, 2, 3, 4, 5, 6. Ignore this dash that has come in between. So here it is 5, 3, 8, 9, 9 and 20, 20, 20 here. It is 15, 11, 13, 5, 13, 6, 5, 4, 0, 10 and 20. Right. So now what we have to do is we have to solve it by WAM method. Right. So I think you can solve it, but let's try it together, because we have to finish this numerical in this practical at least. So let's try with this WAM solution. So when we start with the WAM solution, let's find out the penalties for column 1. So 6 minus 5, it is okay. We have to write supply and demand also. So supply and demand, that I will be writing. So here it is 74, 94, 69, 39, 119, and here it is 50. Right, here it is 140, 190, 150. Let's calculate the penalties for column 1. 6 minus 5 is 1. Nextly, it is 5 minus 3, which is 2. It is 8 minus 4, which is 4. It is 5 minus 0, that is 5. Nextly, we have 9 minus 10, 10 minus 9, which is 1. Here it is 0. For the row 1, we have it as 5 minus 3, that is 2. For row 2, we have it as 5. And then the larger number than 5 is 11. So 11 minus 5 is 6. And then we have for row number 3, it has 5. So 0 minus, so 4 minus 0 is 4. Right. So the larger penalty is 6, and we can do allocation in this particular cell. The maximum allocation that we can handle here in this cell is 39. Right. So we are going to exhaust this particular cell 39. So 190 minus 39 will be 151. Right. Now recalculating the penalties. So this will be gone. Yeah. So recalculating the penalty for column will be 6 minus 5, that is 1, 5 minus 3, that will be 2, 8 minus 4, that is 4, 10 minus 9 will be 1, and 20 minus 20 is 0. So for recalculating it for the rows, it will be 5 minus 3, that is equal to 2. Now the penalty for this row number 2 will change. It will be 13 minus 11, that will be equal to 2. Right. Nextly, we have the penalty for next row to be found out. It was previously 4, and now it will be 5 minus 4, that is equal to 1. Right. Let's move ahead. So we have the maximum penalty as 4 for column number 3, and the allocation can be done in this particular cell. The maximum allocation that we can do is 69. So here we'll be doing it at 69. We'll be exhausting this complete column. We're reducing this penalty, and 115 minus 69 will be equal to 46. Right. Let's move ahead. Recalculate the penalties again. 6 minus for the column 6 minus 5 is 1. 5 minus 3 is 2. Right. These two columns got exhausted. Nextly, we have 10 minus for column 5. It's 10 minus 9 is 1. And 20 minus 20 is 0. For a row, now we can recalculate the penalty. It is 5 minus 3 remaining same, that is 2. For row number 2, the recalculating penalty, we have 11 minus 13 minus 11 as 2. And for row number 3, recalculating the penalty, we have 5 minus 6, 6 minus 5 as 1. So the maximum penalty is observed for three particular instances, right? So which instance, three particular occasions. So for row number 1, the penalty is 2, right? 5 minus 3 is 2, and we can do the allocation here. The maximum allocation that I can do here is 94, right? So nextly, for row number 2, the maximum allocation that I can do here is in this particular cell, which is 94 only. Similarly, for column number 2 also, the allocation can be done in this particular cell only. So we can now for arbitrarily we have to select in which cell we are going to do allocation. So I personally feel that I will be doing the allocation in this particular cell. So 94 0. So this and this will get erased, and 140 minus 94 will be equal to 46, right? So even this particular column will get erased. Let's recalculate. It is 6 minus 5, 1 for column number 1, 10 minus 9 for column number 5, and 20 minus 20 for column number 6. For row number 1, let's recalculate the penalty. It will be 9 minus 1, 9 minus 5, that will be equal to 4 here. For column number, for row number 2, it will be 15 minus 13, that is the penalty remains 2 only. And in row number 3, right, so the penalty will be 10 minus 6, and the penalty will be here will be 4. So again we have a tie. In row number 1, we can do the allocation in this particular cell, and the maximum allocation that we can do is 46. Similarly, in row number 3, the maximum allocation that can be done in this particular cell, and the maximum allocation that I can do again is 46 only. So here again it is a tie. So we are going to solve the tie arbitrarily. So I'll be doing the allocation in this particular cell. 46 here, and here I will be making it 0. 74 minus 46 will be equal to 28, right? So this is all these cells will get exhausted. Let's recalculate the penalty. For column number 1, it will be 15 minus 6 this time, and it will be how much? It will be 9. For next column, it will be 11 minus 5. Column number 2 is already exhausted, 3 is exhausted, 4 is exhausted. Column number 5, it will be 13 minus 10 now. 13 minus 10 will be equal to 3. For the last column, we have 20 minus 20 as 0. Row number 1 is already exhausted. For row number 2, the penalty can be done as 15 minus 13. The penalty is 2, and it will be carried forward. For row number 3, it will be 6 minus, it will be 10 minus 6, that is equal to 4. Now, what we are going to do is, the maximum penalty is obtained for row number 1, and the column number 1, and the allocation that we can do is in this particular cell. So the maximum allocation that I can do in this cell is 28, right? So I'll be exhausting this particular cell. I'll be putting a dash here, and 46 minus 28 will be equal to 18, right? Now recalculating the penalties, can we calculate the penalties? Yes, it will be 20 minus 13 is equal to 7, right? And it will be 20 minus 10 is equal to 10. So for column number 3 and 4, we have to use it now wisely, because not many are pending. So in here we can calculate the penalty, right? So here it is 20 minus 13, that is equal to 7, and here it is 20 minus 10 is equal to 10. Now we can do the maximum allocation in which particular cell that we can have to decide. All right, so how we can do the allocations now? Anyone? Yeah, we have only 18 pending here. So the maximum allocation that we can do is in this particular cell, which is 18. That will be done. So 18 dash will be 0. So 119 minus 18 will be 101. So right. So 101 allocation is required in this cell. So I'll be doing it 101 here. If I do 101, so 50 will be pending. So 50 allocation here. And here I'll be putting it to be 0. Right. So now you can see the entire VAM solution is ready. I'll be copy pasting it on the next page, and then we'll be checking if this is an optimal solution or not. The process is going to remain same. Let's check the optimality. So the number of allocations that we have is how many? 1, 2, 3, 4, 5, 6, 7, and 8, right? And the m plus n minus 1 is 6 plus 3 minus 1 is also equal to 8, right? So we can proceed. So here number of allocations is to 8, and m plus n minus 1 is also equal to 8. Hence we can proceed. So for check of optimality, right? So I'll be redrawing this again. We have to find out u1, u2, and u3. So here it will be 1, 2, 3, 4, 5. This is the D. So this will be v1, v2, v3, v4, v5, and v6. Right. So I will just copying all the RAM solution here. So it is 546, 394. Right, it is 8, 9, 9, and 20. It is 15, 11, 13, 15, then it is 13, and 20. We have 6, 5, 4, and then we have 0, 10, and 20. So 10 is 18 here. Okay. So this is the RAM solution. Number of allocations 1, 2, 3, 4, 5, 6, 7, 8. So for all allocated cells, what we can write is so we can write u1 plus v1 is equal to 5, u1 plus v2 is equal to 3, u2 plus v4 is equal to 15, u2 plus v5 is equal to 13, right? Nextly, u2 plus v6 is equal to 20, u3 plus v1 is equal to 6, u3 plus v3 is equal to 4, and lastly u3 plus v5 is equal to 10, right? So what we are going to do is put v1 is equal to 0. So if you put v1 is equal to 0, you will be getting u1 as 5, right? u1 is 5, therefore v2 will be equal to minus 2. v2 is equal to minus 2. Nextly, u2 plus v4 is equal to 15. We can't put anything here. u3 is equal to 6 because v1 is equal to 0. So 6 plus v3 you'll be getting as 4 minus 6, that is minus 2, and v5 you'll be getting as 10 minus 6, that is equal to 4. So we can substitute all these values here. So u2 plus v5 is equal to 4. u2 v5 already we know the value as 4. So u2 is equal to 13 minus 4, that is equal to 9. So v6 will be 20 minus 9 will be equal to 11. Lastly, we have got u2 value as 9. So v4 value will be 15 minus 9. 15 minus 9 is equal to 15 minus 9 is equal to how much? Oh, have we done any mistake or it is right? v1 value, sorry, u1 value is coming out to be 5, v2 value is coming out to be minus 2, v4 value is coming out to be, let's check if you have done let's cross check this. u1 plus v1 is equal to 5, u1 plus v2 is equal to 3, u2 plus v4 is equal to 5, u2 plus v4, u2 plus v4. Are there any? Okay, u2 plus. It is not 15, it is 5. Okay, it is 13, that is okay. So we have got V4 as wrong, right? I'll be checking it, no, 13, 20, so 6, 4, 69. Okay, other all values are okay. So no, U1 plus, it is U2 plus V4 is equal to 5, U2 plus V5 is equal to 13, U2 plus V6 is equal to 20, U3 plus V1 is equal to 6, U3 plus V3 is equal to 4, U3 plus V5 is equal to 10, right? So according to that, V5 is equal to 4, V3 is equal to minus 2, U3 is equal to 6, V6 is equal to 11, U2 is equal to 9, right? So now we have put 9 here. So yeah, V4 will going to change. So 9, 5 minus, it will be minus 4. V4 is equal to minus 4, right? Similarly, V2 is equal to minus 2 and V1, yeah, we had only one mistake, right? So it is minus 2. So I'll be writing all these values again. So V1 is 0, V2 is minus 2, V3 is again minus 2, V4 is minus 4, V5 is 4, and V6 is 11. Here it is 5, 9, and we have got 6, right? So for all unallocated cells, for all unallocated cells, what we are going to do, we are going to find out the Pij values. So firstly, it will be for P13, it will be P14, P15, and P16. It will be P21, P22, P23. It will be P32, P34, and P36. All these values we are going to solve. So for P13, if we do, it will be 5 minus 2 is 3, 8 minus 3 is 5. For P14, it will be 5 minus 4 is 5 minus 4 is 1, 9 minus 1 is 8. For next 5 plus 4 is 9, 9 minus 9 is 0. For P16, it will be 5 plus 11 is 16, 20 minus 16 is equal to 4. For P21, it will be 9 plus 0 is 9, and 15 minus 9 is 6. It will be for P22, it will be 9 minus 2 is 7, and 11 minus 7 is 4. For P23, we have 9 minus 2 is 7, 13 minus 7 is 6. For P32, we have it as 6. P32, 6 minus 2 is 4, and 5 minus 4 is 1. P34, we have it as 6 minus 4 is 2, and 0 minus 2 is minus 2. Okay, and P36, we have 11 plus 6 is 17, and 20 minus 17 is 3. Here you can see that one of these cell evaluation is negative. So what we can write is that optimal solution is not reached. Iterate ahead by doing allocation in P34, right? We'll have to do the allocation in P34. So which is P34? P34 is this particular cell, right? P34 is this particular cell. So the loop formation is very easy. Here you can see the loop is getting formed very easily. So here it will be plus, here it will be minus, here it will be plus, and here it will be minus. So if you consider minus signs, so here we have 39 and 18. 18 is to be selected as it is the smallest value, right? So 18 will be selected, and we are going to do the allocation. We are going to consider 18 only. So the new solution that is going to be obtained here is, therefore new solution obtained is 3, 4, 5, and 6. Right, so it is 1, 2, 3, 1, 2, 3, 4, 5, and it is D right here. So The new solution that will be I'll be writing here, that is, let me write 538 9 9 20. So 15 11 13 5 13 20. It is 6 5 4 0 10 20. All right. So new allocation, no, new solution is like this: 46 94. So 28 69. So here we have 18. 39 minus no 39 minus 18 will be equal to how much? It will be equal to 21. That will be here. So 101 plus 18 will be 119. That will be here, and 18 minus 18 will be 0. So the number of allocations that we have again here is 1 2 3 4 5 6 7, and it was 8, right? So the number of allocations here is, number of allocations is 8, and m plus n minus 1 is also equal to 8. So hence we can proceed. We have to check for the optimality. Check for optimality. So we are going to check for the optimality. So no, here again it will be u1, u2, u3. It will be v1, v2, v3, v4, v5, and v6. Right. So let's let's address this. So for all allocated cells, what we are going to do is, we are going to write u1 plus v1 is equal to 5, u1 plus v2 is equal to 3, u2 plus v4 is equal to 5, u2 plus v5 is equal to 13, u2 plus v6 is equal to 20. Next we have u3 plus v1 is equal to 6, u3 plus v3 is equal to 4, and u3 plus v4 is equal to 0. So we have all this into our consideration. Let's solve this. Put v1 is equal to 0. So if we put u1 is equal to 0, u1 is equal to 5. So if u1 is equal to 5, v2 is equal to 3 minus 5, that is minus 2, right? So similarly here u3 is equal to 6, v3 is equal to 4 minus 6, that is minus 2, u3 is 6, so v4 will be equal to, no, v4 will be equal to minus 6. Similarly we can carry forward all this here. So v4 is minus 6, so here u2 will be equal to 11, right? u2 is 11, therefore v5 will be 2, right? And u2 we already know it is 11, so v6 will be equal to 9. So putting all these values, substituting here at the places, 5, 11, 6. So v1 is 0, v2 is minus 2, v3 is minus 2, v4 is minus 6, v5 is 2, and v6 is 9, right? So for all unallocated cells, what we can write is, so let's write p13, p14, p15, p16, right? So p21, p22, p23, we have p32, p35, and p36 into our consideration. So p13, you'll be getting 5 minus 2 is 3, 8 minus 3 is 5. P14 you'll be getting 5 minus 6 is minus 1, and 9 minus minus 1 is 10. P15 is 5 plus 2 is 7, 9 minus 7 is 2. P16 is 9 plus 5 is 14, 20 minus 14 is 6. P21 here is 11 minus 15 minus 11 is 4. P22 is 11 minus 2 is 9. 11 minus 9 is 2. P23 you have 11 minus 2 is 9, and 13 minus 9 is 4. For P3 2, you have 6 minus 2 is 4, and 5 minus 4 is 1. P3 5, you have it as 6 plus 2 is 8, and 10 minus 8 is 2. And lastly, for P36, we have 6 plus 9 is 15, and 20 minus 15 is 5. Right? So here what you can say is that all cell evaluations are positive. Right? So here all cell evaluations are positive, hence optimal solution is reached. Right? So now I'll be copying the optimal solution again here, because I require a point to be explained. Right, so it will be 1 2 3 4 5 6. You can say it as that's D. Here it is 1 2 3. Here it is 5 3 8 9 9 20. You have 15 11 3. Sorry, 15 11 13. 5 13 20. You have 6 5 4 0 10 and 20. So you have done allocation here 46. Here we have an allocation of 94, 5 as 21, 13 as 119, 20 as 50 here, 6 28, 4 as 69, and 0 as 18. So now, what we are going to do is we are going to find out what is the total profit, right? In previously, now you have to remember, previously we have added a 20 in one of these steps, but now when we are going to find out the total profit, here we'll have to particularly subtract 20. So for example, you see the cell 11 where we have the unit cost as 5. So what will be the cost now here? It will be 20 minus 5, that is 15. So you'll be taking 15 into 46 plus here it is 3. So 20 minus 3 is 17. So 17 into 94 plus previously we allocated here it is 5. So it is 15 into 21 plus 7 into 119 plus, so here it is 20 minus 20 is 0. So 0 into 50 plus 6, it is 14 into 28 plus 16 into 69 plus, no, it is 0 here. So 20 plus 0 is 20, 20 into 18. Therefore, total profit. So this is maximized profit. So if you solve this, you will be getting the profit of rupees 5,292 rupees.